Ungrounded three-prong outlets are a common issue found during home inspections, and it's crucial to address them correctly to ensure electrical safety. The suggestion of filling the ground slot with epoxy is fundamentally flawed and creates a dangerous situation. It's essential to understand why this method is inappropriate and what the correct solutions are. Firstly, filling the ground slot with epoxy provides absolutely no grounding path. The purpose of the grounding conductor is to provide a low impedance path for fault current to return to the source, tripping the circuit breaker or blowing the fuse. This rapid clearing of the fault protects people from electric shock and reduces the risk of fire. Epoxy is an insulator, meaning it does not conduct electricity. Filling the ground slot with it simply creates a cosmetic appearance of a grounded outlet without providing any actual grounding functionality. Secondly, attempting to create a false ground can be extremely dangerous. If a fault occurs in an appliance plugged into such an outlet, the fault current will have no safe path to follow. This can result in the appliance's metal parts becoming energized, posing a serious shock hazard to anyone who touches them. It also increases the risk of fire if the fault current finds an unintended path through the building's wiring or structure. Thirdly, using epoxy or any other non-approved method to simulate a ground is a violation of electrical codes. Electrical codes are designed to ensure the safety of electrical installations and protect people and property from electrical hazards. Tampering with electrical components in a way that bypasses safety features is a serious offense and can have legal consequences. Now, let's discuss the correct methods for addressing ungrounded three-prong outlets. There are two primary solutions, each with its own advantages and considerations. The first solution is installing a grounding wire. This involves running a grounding conductor from the outlet box to an approved grounding point, such as the service panel or a nearby grounded metal water pipe. This creates a direct, low-impedance path for fault current, providing effective grounding protection. Here's a step-by-step overview of the process. 1. Identify the circuit. Turn off the circuit breaker that supplies power to the outlet you're working on. Use a non-contact voltage tester to confirm that the power is off. 2. Access the outlet box. Remove the outlet cover plate and the screws holding the outlet in place. Carefully pull the outlet out of the box, being mindful of the wires connected to it. 3. Identify grounding point. Locate a suitable grounding point, such as the service panel or a nearby grounded metal water pipe. The grounding point should be readily accessible and provide a reliable connection to the earth. 4. Run the grounding wire. Run a length of appropriately sized grounding wire from the outlet box to the grounding point. The size of the grounding wire should be determined based on the size of the circuit breaker protecting the circuit, referring to the National Electrical Code, or NEC, Table 250.122. 5. Connect the grounding wire. At the outlet box, connect the grounding wire to the grounding screw in the outlet. This screw is typically green in color. At the grounding point, securely connect the grounding wire using an approved grounding clamp or connector. 6. Reassemble the outlet. Carefully push the outlet back into the box, ensuring that the wires are neatly tucked away. Secure the outlet with screws and replace the cover plate. 7. Test the outlet. Turn the circuit breaker back on and use an outlet tester to verify that the outlet is properly grounded. If the outlet tester indicates a ground fault, double-check all connections and consult with a qualified electrician. Installing a grounding wire is the preferred method for grounding outlets, as it provides the most reliable and effective protection. However, it can be more challenging and time-consuming than the second option, especially if a suitable grounding point is not readily accessible. The second solution is replacing the outlet with a GFCI, or ground fault circuit interrupter, outlet. A GFCI is a safety device that monitors the flow of current in a circuit and quickly interrupts the power if it detects a ground fault. This can prevent electric shock, even if the outlet is not properly grounded. GFCI outlets are commonly used in areas where there is a higher risk of moisture, such as bathrooms, kitchens, and outdoor locations. Here's how to install a GFCI outlet in place of an ungrounded outlet. 1. Turn off the power. As with any electrical work, start by turning off the circuit breaker that supplies power to the outlet. Confirm that the power is off using a non-contact voltage tester. 2. Remove the old outlet. Remove the outlet cover plate and the screws holding the old outlet in place. Carefully pull the outlet out of the box, noting which wires are connected to which terminals. 3. Identify the line and load wires. GFCI outlets have 2 sets of terminals labeled line and load. The line terminals are for the incoming power from the circuit breaker, while the load terminals are for any downstream outlets or devices that you want to protect with GFCI protection. In most cases, you will only be connecting wires to the line terminals. 4. Connect the wires. Connect the black or hot wire to the brass-colored screw on the line side of the GFCI outlet. Connect the white or neutral wire to the silver-colored screw on the line side of the GFCI outlet. If there is a bare copper wire, it should be capped off with a wire connector, as it cannot be connected to the GFCI outlet directly in an ungrounded circuit. 5. Reassemble the outlet. Carefully push the GFCI outlet back into the box, ensuring that the wires are neatly tucked away. Secure the outlet with screws and replace the cover plate. 6. Test the GFCI outlet. Turn the circuit breaker back on and press the test button on the GFCI outlet. The reset button should pop out, indicating that the GFCI has tripped. Press the reset button to restore power to the outlet. 7. Label the outlet. Label the outlet as ungrounded GFCI protected. This is important to inform future users that the outlet is not grounded but is protected by a GFCI. Replacing an ungrounded outlet with a GFCI outlet is a relatively simple and effective way to improve electrical safety. However, it's important to understand that a GFCI outlet does not provide a true ground. It only protects against ground faults. If you want to provide true grounding protection, you will need to install grounding wire. It is also important to note that according to NEC section 406.4 D2, when a non-grounding type receptacle is replaced with a ground fault circuit interrupter type receptacle, it shall be permitted to omit the equipment grounding conductor connection. An equipment grounding conductor is what provides a safe path for electrical current to flow in the event of a fault. This exception is allowed because the GFCI provides a level of protection against electrical shock even without a direct connection to ground. The NEC also says that an ungrounding receptacle can be replaced with a grounding type receptacle where it is protected by a GFCI and is marked listed as GFCI protected and no equipment grounding conductor exists. Ultimately, the best solution for addressing ungrounded 3-prong outlets is to consult with a qualified electrician. An electrician can assess your specific situation and recommend the most appropriate and cost-effective solution. They can also ensure that the work is done safely and in accordance with electrical codes. Trying to take shortcuts or using unapproved methods can create dangerous conditions and put yourself and others at risk. Remember, electrical safety should always be a top priority. Before starting any electrical work, always turn off the power to the circuit you're working on and use a non-contact voltage tester to confirm that the power is off. Wear appropriate safety gear such as gloves and eye protection. If you're not comfortable working with electricity, always hire a qualified electrician.